Hi, this lesson we will look at statistic 2, confidence intervals for a population mean from a normal population with known variance. First point, consider a population with unknown mean mu. So the population mean, we call it as mu, if we can find an interval AB such that the probability of the population mean lies in between A and B is equal to 0.95, then we say that AB is a 95% confidence interval for the mu. Now, let's say if I sketch a bell-shaped curve, where the mean, the population mean should be lying in the middle. Okay. So when we talk about confidence interval, the value of A and B will be symmetrically lies on the left and right of the population mean. And the area covered, which is the probability, equals to 0.95. Okay. So in this case, 0.95, which is the probability, is the probability that the interval contains the mean, the population mean, the mu. And the probability that the interval does not contain the mu is 1 minus 0.95 equals to 0.05. So which is here. This is where the interval does not contain the population mean, but part of it on the left, another part of it on the right, as this is symmetrical, bounded in the middle. Okay. Now let's say point 2. The confidence level associated with a confidence interval states how much confidence we have that this interval contains the true population parameter. So for this case, we are referring to the population mean. Okay, the confidence level is denoted by these calculations. So what does it mean by this alpha here? We will look at the point 3. Now, point 3, any value of the confidence level can be chosen to construct a confidence interval. But the more common values are 90%, 95%, 98%, and 99%. All right. So what is the alpha here? So alpha is going to be, if you are choosing a 90% confidence interval, then the alpha is going to be 10%. 95 then will be 5%, 2%, and 1%, and so on, which means the probability is going to be 0.1, 0.05, 0.02, and 0.01. Okay, so that is why, according to the calculations, when you have 1 minus alpha, when your alpha is, which is here, alpha is equals to 0.1, 1 minus alpha is going to be 0.9, right? When you times 100%, that's how you get 90% confidence interval. Okay, so that is the value, the meaning of alpha. Then after that, we have alpha divided by 2. So why do we do that? Because when we refer to the bell-shaped curve, okay, let me erase this. Don't forget, we are looking at the 90%. So, and we are getting the 90% bounded in the middle, symmetrically in the middle. Then the z-score value we are getting is not going to be getting directly, right, from the table, because table will give you the probability all the way to the left, like this. All the way to the left. But what are we looking at is the area that bound in the middle, and it has 0.9. So in order to use the table to get us the corresponding z-score, what are we getting is, see, this area is going to be 0.9, and a smaller region here is going to be what? 0.1 divided by 2, correct? So that's why we have alpha divided by 2. So it's going to be 0.05. So this is 0.05. So when the probability that we want is the total of 0.9 plus 0.05, that means we are going to look at the probability of 0.95 in order to get us the z-score value, which is the z of alpha over 2. Okay, so how do we get the z-score from the table? Now, let me scroll down first to show you the table. Right, you can get this from the MF19, the formula booklet. So in order to find this value, you can scroll down further, look at the smaller table that lies below here. See, the P is the probability, and the z-score is what we need. When we have the 0.95, the corresponding z-score is 1.645. All right. So that is what we found. Okay, now I come back to here. The z-score value is 1.645. So that's why this value found. Okay. Same thing happened to the 0.95, 98, or even 99%. They are corresponding z-score values. Okay, so which means if I'm going to get a 90% confident interval, then the corresponding z-score value will be 1.645 and the negative 1.645 here, right? To give you an area or the probability of 0.9 bounded symmetrically in the middle of the bell-shaped curve. Okay, so now this is the 0.4 will give you the formula where we are calculating the confidence interval. So given a sample of size n from a normal population with variance of sigma square. So for this, like how many percent confidence interval, the population mean will be given by these calculations. Okay, the formula is here. So look at the questions we have, then we try to use this formula to calculate. Or we can just write it down as x bar, which is the sample mean. Then you have the plus and minus. So we have positive and negative of the z-score, right? So z-score emphasize the alpha over 2, right? Which is the value found in the 0.3. Or I just simply write it down as the z-score multiplied with the standard deviations, which is the sigma over square root n, right? This is actually the standard deviation for a sample mean distribution. Okay, we can also write the formula like this. Okay, now I'm going to use this formula, try to find the confidence interval, right? So now we are looking at some partial questions as example here. Now, this is the questions from October, November 17. Last time the paper is called paper 7, but now has changed to paper 6. So it's 7 variance 1. Okay, question 4. So the length in millimeters of rod produced by a machine are normally distributed with mean mu. So that is the population mean, and standard deviations 0.9. So this should be the population's standard deviations given. Okay, a random sample of 75 rods produced by the machine has mean length of 3 300.1 millimeter. So first point, find a 99% confident interval for mute, giving your answer correct to 2 decimal places. So point 1, we are going to find the 99% confident interval for the mute. Right, in this case, the length, the mean length of this rod produced. So according to the formula I have just now, x bar plus minus the z-score multiplied with sigma over square root n. So let's see one by one. Do we have the x bar value given? The sample mean from a sample of 75 rod and the mean length 300.1. Okay, and then the sample size 75. And the population standard deviation is given as well, 0.9. See, we have the values of this one, and this one. So what are we going to do is to determine the z-score. How do we determine the z-score? It comes from this 99% confident interval. Okay, again, must remember that when we are finding the confident interval, it bounds symmetrically in the middle to give you an area of 0.99, which is 99%. So what is the corresponding z-score here? So that is why we are going to find out this. The smaller region here. So taking 1 minus 0.99 divided by 2, right? Because another half is here. So find this. So it's going to be 0.005. So you can see this area is going to be 0.99, and then a smaller region here, 0.005. So when the probability is this, then the corresponding z-score is going to be, okay, refer back to the table I have just now. And certain commonly used confident interval percentage, we can refer to the smaller table below. If we can't get it from the smaller table here, we refer back to the big table above, right, to get back the z-score. So now, so even though we are looking at 99% confident interval, but the probability that we are going to use is 0.995, right, as I shown in the bell-shaped curve just now. Hence, the corresponding z-score is going to be this, 2.576. 2.576. So with all these values found, we can sub in and calculate out the confidence interval. Sigma is 0.9 divided by square root 75. All right, so calculate. So one value is going to be 300.3677. So 37. Question says keep to 2 decimal places. So going to be 300.37. Then another value, $299.8323. So it's going to be 299.83. All right. So we found the confidence interval. So either you can write your answer like this, seems like a coordinate, or you can say that it's 299.83 to 300.37. Okay, so that means we have 99% confident that the population mean, in this case, is referring to the length of the rod produced. The mean length produced should lie in between 299.83 to 300.37 in millimeter. Okay, 99% confident. Now, the manufacturer claims that the machine produces rod with mean length of 300. Okay, part 2, use the confidence interval found in part 1 to comment on this claim. So as you can see, this confidence interval tells us that we have 99% confident that the population mean would lies in between 300.37 and 299.83. Okay, so it does include, or it does contain the 300. So the manufacturer claims is supported, right? Because we have 99% based on our calculations, the population mean should lie within these two values. And since the manufacturer claims the rod has the mean length of 300 mm, then the claim is supported. So the confidence interval contain or include 300, hence the claim is supported. All right. Okay, now we have a look of another questions. So this is the question from May, June 18, right? Same, the variant 7.2 and question 3. So the management of a factory wish to find a range within which the time taken to complete a particular task generally lies is given that the times in minutes have a normal distribution with mean of mu, right, the population mean, and standard deviation 6.5 given. A random sample of 15 employees was chosen and the mean time taken by these employees was found to be 52 minutes. Part 1. Calculate a 95% confidence interval for mu. 95% confidence interval for mu. So same, we have the formula. Okay, let's see. From a sample of 15 employees, the mean found to be 52 minutes. So the sample mean we got, and then the sample 15 employees as well as the population standard deviations given to be 6.5. So same thing, what we're trying to do is to find out the z-score. Okay, how do we obtain the z-score? It comes from the 95%. So in order to get ourselves 95%, that bounds symmetrically in the middle, then the value, the probability that it does not lies within the 95 is going to be this. Right? What am I getting? 0.025. So this area is 0.95. And the z-score we want is from here all the way to this, right? So we're going to plus the smaller region here, 0.025. So that's why So in order for you to get a 95% confidence interval, the z-score value has to be referring to the probability 0.975. Okay, so I'm going to scroll up to refer back to the table we have just now. Now again, if we get to see the value from here, 0.975, yes. And then I will take the corresponding z-score from here, 1.96, right? If I couldn't get it from the smaller table here, I will read from the table above to get to the z-score. Okay, the z-score, 1.96 found. Then we are able to find out the confidence interval. Right, so can calculate. So we keep to 3 significant, 55.28. So 55.3. Then another value. (48.71), 48.7 then. Okay, or 48.7 to 55.3. So that is the confidence interval, that the times in minute, which is the mean time that the employees take to complete a particular task. Okay, we have 95% confidence that the mean time taken by the employees to complete a particular task would lie in between 48.7 minutes to 55.3 minutes. Okay. So now, later another 95% confidence interval for meal was found based on a random sample of 30 employees. So you can compare. In the beginning, the sample was 15 employees. Now we increase to 30 employees, double the sample size. So part 2 state with a reasons whether the width of this confidence interval was less than, equal to, or greater than the width of the previous interval. So what happened? The interval for this case with a sample size of 30 is going to be narrower or less than. Because you see, based on the calculations, the sigma over square root n, right? When the sample size from 15 increased to 30, that means the value n here is bigger, and simply mean this is going to be smaller. So if this value is smaller, then your confidence interval will be narrower or less than. Right, the width will be smaller. So that's why answer is less than, because of the sample size increase. And this value, the standard deviation, will be smaller. Okay. So we're done with these questions. Finding the confidence interval using this formula, and a little bit explanation about the confidence interval. And that's all for these lessons. Please subscribe to the channel and like these lessons. I see you in the next one. Bye-bye.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub, will get genius teachers to fulfill your request for the solution. Genie, we'll see you next time. Bye-bye.